Okay, guys, we're on our last section on the area chapter. So, like I said in our last homework or last assignment, we're going to spend 2 days on what's called geometric probability. I'm going to start you guys off with just talking about probability, just like regular probability, not geometry probability, but like the normal stuff that you probably learned in middle school or in Algebra 1. So, if you want to find the probability of an event happening, you take what's called favorable outcomes and you put it over total outcomes, and that would give you the probability. So in this case, if I had a standard die, you guys all know a cube is a die. There's a 1, a 2, a 3, a 4, a 5, and a 6 on it. So I can use this die to find the probability of rolling, pretty much anything I want. So what I wrote here down is this is the notation. The P and then in parentheses is what you're trying to find the probability of. So this problem right here, example number 1, would say, what's the probability that you roll a 3? So if I took this die and I rolled it, I got a 6, I got another 6, I got another 6, I got a 4, I got a 6, 6s are high here, and then I finally get a 3. What's the probability, though, if I only roll it once, that I end up with a 3? So what it ends up being is this fraction. It's the favorable outcomes, meaning when you look at a die, how many of them are this? So there's 6 sides to a die, and only one of them is a 3. So that would be one favorable outcome. Only one of these 6 things is what you want. You want a 3. Out of the total number of outcomes means how many different things could have happened? 6. And you get 1 out of 6. The thing about it is, for what we're going to be doing, we won't be leaving the answer as a fraction. That's the fractional form. What we're going to be doing is we're going to be finding the percent for that. So it's pretty easy. It's just division. So if you want to change a fraction into a percent, you're going to divide them first. So that would be 1 dividing by 6 and gives you this decimal. And then you got to take that decimal and you got to multiply it by 100 because that's the decimal version. So you're going to multiply that by 100. And that will give you the percent. And I want that rounded to 1 decimal place. So you divide them. Then you're going to multiply by 100. And in this problem, that'll give us 16.7%. That's the percent chance of rolling a 3. And that's how we're going to do all of them. So for all of them, you're initially going to get a fraction. You'll divide the top divided by the bottom. Then you'll multiply by 100, and that will give you your percent answer at the end. Make sure you round it right. Okay, one more with the die. So what if I said, what is the probability of rolling an even number? So probability that I roll an even number. So, just like before, you got to look and see how many favorable outcomes. If you look at all 6 sides, how many of them are even? Well, 2 is even, and 4 is even, and 6 is even. So 3 of them are even. So that's your favorable. So it would be 3 out of, for a die, the denominator is always 6. Now, if you wanted to, you could simplify that to 1/2, because that's what it is. But since we're going to change it to a percent, you don't need to simplify anything. You could just do the division and the multiplication and get the final percent. Now, 3 out of 6 is 1/2, which is 50%. So this should come out to be 50. So let's double check it. So I got 3 divided by 6, 0.5. Multiply that by 100, and that's exactly what we said it was going to be. There's a 50% chance, and that would be your final answer. 50%. Okay, so that's the basic lesson on probability. Now let's talk about geometric probability. So here's what I got going on here. All right, so I'm going to use an example I think you guys will understand because you've probably seen it before. You're going to have to draw this. So I'm going to draw a circle with another circle inside, a smaller one. So I got 2 circles. I'm going to tell you that the big circle has a radius of 10. And the little circle, this little guy right here, has a radius of 2. This is a 10. This is a 2. Because that's the important things that you need for circle. This will be our first example. Okay, so what we're going to have to do is we're going to have to find the area of both those figures. So let me explain what geometric probability is. So this is a dartboard. That's the reason I gave you this example. What geometric probability, guys, is what is the probability that if you chose a place on the entire figure, just randomly, if I close my eyes and just pointed and I hit there, or I close my eyes and I hit there, the problem you're trying to figure out is what is the probability that you would end up in whatever it is you're trying to find. So here's this example. What is the probability that I would end up in the small circle? That's what I'm trying to find. So if you think about it, the small circle is so small compared to the whole thing, it's probably a pretty small number. You know, it's not like it's going to be 50% because I could close my eyes and just start hitting dots everywhere, and I might not hit in that circle at all. So that's what I'm trying to find. I'm trying to find what would be the probability that I would end up in the small circle if I just randomly chose a place. Now, what you're going to do is you're going to find that now we're going to do area instead. So this deal up here with this formula, same idea, except what you're now going to be doing is you're going to be doing the area. So here's the actual formula for a geometric probability. The probability of an area is equal to the favorable area over the total area. Now remember what favorable is. Favorable is whatever's in that parenthesis. So I'm going to have to find the area of whatever's in that parenthesis here in the problem and put that over the area of the whole thing. So in this case, I'm going to find the area of the small circle and put it over the area of the big circle. So area of a small circle. I'm going to need a little room. Area of the small circle. Area is equal to pi r squared. If you don't have that formula, please write it down. And I'm going to be putting that over the whole figure, which is a big circle. Area of the big circle, which is also pi r squared. Okay, so the small circle, the radius is 2. So this is going to be pi times 2 squared over the big circle, the radius is 10. Pi times 10 squared. And that's it. Put it in your calculator, get each value, and then we'll convert that to a percent. So let me, I'm going to drop down here. So now we're just going to use my calculator. So I'm going to put pi times 2 squared in there. Now if you want to square first 2 and get 4, that's fine. I'm going to do it all at one time. So pi times 2 squared. Which, like I said, you can square 2 first. If you want to do 2 squared and get 4, then you could just do pi times 4. You get the same answer. So that's going to be, what is that, 12.6. We're going to round it to 1 decimal point over, now do the same thing with the bottom. Pi times 10 squared is 314.2. Once you have those two numbers, then we're exactly the same up here. We're going to divide them, and then we're going to multiply by 100, and that'll give you your final answer. So I'm going to take the top, divide it by the bottom, always. So it's 12.6 divided by 314.2. Gives you that number right there. Multiply that by 100, and there's your final answer. That would be 4.0%, so 4%. Which makes sense because that is such a small part of the whole figure that you would think that it would come out to be a small percent. If I made a bigger circle, it would be a bigger percent.